Professor كبار, Professor Alexander Maxenberg, and Professor للعام. Our first speaker will be Professor كبار. He's well known as a scientist in the States and in the Arab region. He is the researcher and director for the Center of Remote Sensing in Boston University. And he is the former investigator, principal investigator for the Earth observation and photography on the Apollo-Soyuz test project, which works with NASA, and the science advisor to Egypt, to President Sadat, and he is member of the advisory board of President Sisi of Egypt right now. He is well known in geology, hydrology, and water resources. His fame came from the NASA work on the Apollo-Soyuz. I would like to welcome you, Professor Farouk Elbaz. His lecture will be on the use of space technologies for natural resources and exploration and management. Myself and Mohammed Hassan, we will monitor this talk. After his speech, we'll go to the second and third speakers, and then we will open the floor for discussion and question to the three speakers. Farouk.
It's the least amount of rainfall anywhere in the world. And go ahead. Yeah. I would like to start by telling you a little bit about what satellite images are. Basically, you wait for sunlight to hit the Earth, and then it is reflected, or if it is not sunlight, it's a radar wave that hits the surface of the Earth and gets reflected back, and we measure that reflection, the back reflection, and then look at it and interpret it, enhance it, do all kinds of things to it, until we see what is it that we can learn from that specific view. So it is views of the Earth and the different parts of what we call the electromagnetic spectrum. And that is something that would change from the wavelength of X-rays all the way to the TV and radio, with a very small segment there in the middle, which is the visible. And the visible is basically you have the blue and green and red. These are components of the white light, and they are part of that electromagnetic spectrum. And in remote sensing, we apply all of the segments of the electromagnetic spectrum so that we can understand the complete properties of the Earth based on the way the surface materials reflect or interact with some of these rays, whether it's X-ray, radar, and blue light, red light, and so on. And in the visible, that small range in the middle, these are the pictures that we see, and these are the pictures that you and I take with our iPhone, and all of the pictures that we see, this is in the visible part of the electromagnetic spectrum, which is something that results from the sun solar radiation that's reflected back into this blue, red, and green. And here is a view of the Earth from the Apollo 11 mission, and you can see very clearly the borders of Africa and the Arabian Peninsula and a little bit of part of Asia. And the astronauts, while they were on the moon or on the way to the moon or back from the moon, they always wondered about this fact that the only part of the Earth that they actually recognize the geology or the geography of is the Middle East or Africa, because of the lack of clouds. So you can see very clearly here the clouds cover a great deal of the north and the south and all of the equatorial portion, but the north here, north of the equator, you can see all of North Africa and the Arabian Peninsula. This is the Persian Gulf, and Iran. And here is a little bit of South Africa, meaning that it is nearly always free of clouds. And we utilize the fact that it is always free of clouds, which makes it much easier to actually look at from space. And the fact that it is free of clouds also tells us something else. Tells us something that relates to the amount of solar radiation that reaches that place. You can very clearly here see the borders of North Africa. There is the Red Sea, the Arabian Gulf, and you can see very clearly the details of the surface region, which is the largest desert on Earth. And this largest desert on Earth is also the driest place on Earth, or includes the driest place on Earth. We compare the dryness by measuring the aridity index. That aridity index is the relationship between how much solar radiation comes to the place in relation to the rainfall. And that is the relationship here. And the yellow color in all of North Africa right here, this yellow zone, which includes part of Egypt, part of Sudan, and part of Libya, that is the driest place on Earth. And the line around it is marked here 200. And 200 means that the solar radiation is capable of evaporating 200 times the amount of rainfall. Meaning the rainfall is so tiny that the solar radiation, if the rainfall was 200 times the amount that received by Earth, the solar radiation is able to evaporate it. And that is why it is the driest place on Earth. And then you can see the rest of the colors. These vary from 50 to 100 or 10. This means that it is a peculiar part of the Earth. It's a very special part of the Earth. It is unique because the dry places in other places in the world are very different and much less dry than this corner of Northeast Africa. For example, the driest place in North America is in the state of California. It is called Death Valley, Wadi al-Maut. Death Valley because it is so dry and miserable. So it's called the Death Valley. And the dryness number for Death Valley is 7. And the driest number of all our desert here is 200. This is how dry can be. Now this dryness makes it very clear that there will be absolutely no vegetation, because vegetation cannot exist without water. So if there is dryness and there is no rain, then there will be no vegetation. And that's why you see in our deserts that there is very little. Very little. So you can see the effects of the wind coming in from the north and going towards the south. The wind always comes from over the Mediterranean, veers into to the right, and it comes in from the north towards the south. All of these lines are lines of sand dunes. All of these lines here are lines of sand dunes. So because the wind comes from here and veers like this and comes in like that and actually turns in like that. So it's a circular motion like this. And this is how all of the lines of the sand dunes are coming this way around high topographic areas. High topographic areas, I'm going to show you that one here, right here, which is called the Gulf Kebir Plateau. This is just about the border between Egypt here, Sudan here, and Libya here. So near the border between Egypt, Libya, and Sudan. And there, what you see it like this, the Gulf Kebir Plateau. One of the first things that we noticed when we looked at satellite images of this region is the fact that on the border of the plateau, which is about 300 meters high, you can see these pieces of dry valleys, dry, eroded courses of water. Actually, when we saw things like this on the planet Mars, when we first took pictures of Mars, this was the first time that we realized that the planet Mars had water, because this kind of geographic feature cannot form except with running water. And this meandering is part of the erosional ability of water. So when you go there and you see this, then you can see that there was a great deal of water that actually formed all kinds of rivers and streams. in this kind of very dry environment, what you mean rivers and streams? So there must have been rivers and streams in the past, not today, because today there is not enough rain to form these kinds of features at all. And indeed, in some of these valleys we find very thick clay deposits from the deposition of lakes, meaning that this is a lake deposit and it can reach up to 24 feet, meaning that there was quite a bit of water for a deposit to form in 24 feet. Nearby we see evidence of houses for the people that lived in this part of the world before. So the circles, actually before the ancient Egyptians, all of housing anywhere in Jordan, in Asia, everywhere houses were kind of circles. You form a circle, you put a stick of wood or something in the middle, and you cover it with cloth, and so there was always circles before the ancient Egyptians started this notion of angular structures. So all of these things that we see are 5,000 years old, and this particular one was dated by association of the things around it to be about 6,000 years ago, and by association meaning the things that we find around it. Like this one, the archaeologists call it the core rock. It's a very hard quartzite, silica, meaning very hard rock, that the ancients would have chipped pieces from it to form their own knives and the things that they used to cut the animals or cut the skin of the animals out and so on. And these here had been dated from about 6,000 to 20,000 years ago. So there was quite a bit of human habitation at the time when it used to rain over there. And we can see in the middle of the desert, and where you can drive for 500-600 miles or kilometers and not see a living grass, not a single blade of grass, nothing, living. And then you see a grinding stone and a milling stone. This is something that is used to grind wheat or corn or whatever it is, to make bread, to make the flour. So what was that when you're in the middle of nowhere and you can see this, when you realize that, it must have been from some time ago, when it used to be of all kinds of things. And indeed we can find ostrich eggshells all over the place, particularly in a place between the border between Egypt and Sudan. There is an oasis called Salima, Wahid Salima, and this oasis is surrounded by remains of ostrich eggshells. We age-dated them by the carbon-14 method to vary between 6,000 and 11,000 years ago, meaning that between 6,000 years ago and 11,000 years ago, that particular area was a lake with all kinds of grasses around it, and around these grasses there were all kinds of giraffes and ostriches, and these are the ostrich eggshells from that period of time that varied between 6,000 and 11,000 years ago, meaning way before the ancient Egyptians or the Kush civilization in Sudan, way before that, from 5 to 6,000 or 6 to 11,000 years ago. And here we find that somebody took an ostrich eggshell, and like this here, and make them round, and actually drilled the hole in the middle, and we found the mechanism where they did all of that, and then he made a necklace for his wife or girlfriend out of ostrich eggshell, little circles like that. And it's fascinating to see that humans had been utilizing this land very nicely and very cleverly. In the Gulf of Gulf Kebir Plateau, as well as the Awaynat Mountain right at the border between Egypt, Libya and Sudan, everywhere on the walls or in caves or in anything that you can see that people used it to shade from the sun or from the rain, we find depictions of animals on the walls. So these are artistic drawings of the animal life that used to live there. And from this particular piece, we figured that there was a change in time of the fauna that lived there. Because we can see several stages of animals in here. This one here is a giraffe, and it is the most faded feature. And then this one here is an ostrich. This is the neck up here. And this one here is a baboon, ird, right here. And then there are 3 cows. That one actually tells you that there was a stratification of time. There was a change in time of the amount of vegetation, and therefore there was a change in time in the type of fauna and the animals that lived in that place. First, there were all kinds of vegetation and all kinds of trees, high trees, for the giraffe to be able to reach the leaves of the trees and eat from it. And then there was a change, where there was only a savanna-like environment, where only giraffes, where only ostriches and baboons could live. And then there was another change, where only the grazing animals used to be, or could survive in there. So we know that the conditions of environment were changing from very wet to form the trees, to a little bit savanna-like environment, and then grazing animals, and then there were none, and we see absolutely nothing. So there was a great gradation of the living things in this desert to tell us that there was the change in the fauna, and the change of the environment was gradual, and it started from very wet all the way until you get to the dry, and then it stayed dry to this day. So the desert that we see today was actually formed in its shape that we see it today somewhere between 5,000 and 6,000 years ago. So that desert that we look at, we have nearly throughout the place we can see the wind pattern coming in from the north, coming out down this way with a few oases in the middle, and that's the nature of whatever we find in the desert, except for the fact that if we look at the plateaus, the high areas, as I told you, we had these rivers coming out from the plateaus. We followed that particular one that I showed you earlier, and most of the channels were heading to the east, towards the Selima Sand Sheet, which is the former lake that was here, and another flat area right here, and that's what we begin to see. Yes, when it used to rain in the highlands, the water took path, and there were all kinds of rivers that led to this particular low area, which must have had a great deal of water in the past. So when we say geologically there was a great deal of water in the past, that means that there must be some of that water at the present. Why? Because when the water lies on top of the ground, if that ground is porous, or the material, the layer beneath that water is porous, then the water will find its way through the pores of that rock and will remain there, and it will stay put. Meaning that if you find in the desert old drainage patterns, old wadis and old passageways for water, then the places where these wadis lead to must have been places for storage of water, because must have been a kind of a lake at the time when it rained a lot at that time. And this is where we see in this particular area where this, we interpreted this area right away that there will be groundwater in here. And as soon as we did that, the pictures that we took from radar showed us this kind of topography in 1982. I took this to the Minister of Agriculture, who was a good friend of mine, Yusuf Wali, for those who know. And I started telling him that we need to begin to examine this place in case there is water enough for agriculture. So he said there is absolutely, I asked all of the people in the ministry and so on, there is absolutely no way that this kind of desert would have any groundwater. I said, okay, but let's drill one well to see, check. Anyway, it took me 13 years to discuss with the Minister of Agriculture, who was a good friend of mine, to try to convince him to drill just one well to see, because everybody else said there is no way. It is a desert area. There is absolutely no water. It couldn't be. Every time I go to Egypt, I'll go visit with him and sit down and talk to him and show him something and discuss it. And 13 years. Finally, in 1995, he said, I was once entering his office, And even before I shook hands with him, he said, I'm going to drill 2 wells to shut you up. So, so they did. And the water came rushing, because there is a great deal of water there. It is very sweet water. It comes out from the ground nice and cool. It has absolutely no salts. It's cleaner than Nile water because it has not passed through all the cities and towns and villages the Nile has to go through. It is just, there was rain, and it went through the clean sandstone rock, and it stayed there put, and it is nice and clean and stays cool, and that's where we began to divide this area into plots and to do circular irrigation. And now, today, there are 250,000 acres that are viable for agriculture, and the water that was proven by the many, now there is 12,000 wells already pumping water, and the water that comes out from this well is calculated that the water that's proven that will be good for agriculture over 250,000 acres is good enough for 100 years. And this is the wheat being produced there. And very much like this is in Libya. We know of an area called Kufra, near the Kufra oasis, where an American company was exploring for oil, and they started with this circular irrigation near the Kufra oasis. And we know this pattern and so on from satellite images from the Apollo-Soyuz mission. We saw this very interesting pattern that looked to me like a goat. This is the head and the body and the front legs and hind legs. The Kufra oasis itself is somewhere in this S-shaped area, but this is the pattern of the circular irrigation farms there. And we never really knew why this pattern is like that, because they drilled wells all over the place in here. It did not provide water, but only water came through when they drilled in that passageway only, in this, and so on. We never knew why. Until 1982, when we got the radar images from the shuttle, and we found out the reason why. The reason why this in the here is the old Kufra oasis, and there is the pattern, the goat. Here is the body and front legs and hind legs. That shape is completely controlled by a wadi. This was a river coming in from the Tibesti Mountains right here, and this river here is coming from the Gilf Kebir Plateau of Egypt, and they meet near the Kufra oasis, and every well that was drilled away from the river pattern did not have water, but the river, all the wells that were in the passageway of the river that's coming from the Gilf Kebir provided a great deal of water, meaning, yes, indeed, now here is a passageways of water that came from highlands. It never rained here, but the highlands here had the water, and the water passed right through. So this is a pattern that we begin to figure out that exists, and we began to think about a nearby area in Darfur. When the problems of Darfur started, we began to look at it because we had this is the Salima Shamsit here along the border of Egypt. This is the Kufra oasis, what's right there, and then we saw this Darfur, that there might be some similar situation in Darfur, particularly because there was a small area of flatness right here in the North Darfur, very much like the Salima Shamsit in Egypt, and we began to look at it and explain it. Here is why the radar shows us things beneath the surface of the desert. On the left are 2 Landsat images showing very little at all, just a few color variations, but nothing of the surface. And between the 2 white lines there, the 2 white lines are the border of the radar image, the radar path of the shuttle. And on the left is just the regular Landsat image, the optical image, the blue, red, and green. And on the right is the radar image within the same place. And it's across here is about 50 kilometers, this width right here. So this is the Landsat image, and this is the radar path. It's over them. And what you see here are 3 rivers. One that's 8 kilometers across, that had all kinds of branches here. One that's 12 kilometers across, with 2 very large branches here, and one that is 20 kilometers across. So these are very large rivers that must have formed when there was a great deal of water from a great deal of rain. So this was in Darfur, and we never followed the place until we were able to put all of these pictures on top of some other pictures. There is the picture that I showed you first right here, and then we can see this, something like this. That all of these rivers led to a very large flat area that received water from this Nadi mountain range, and this was the flat place that was the at one time before 5,000 years ago a very large lake. And because it was a very large lake, then there would have been water beneath it and so on. And so we took the details and we figured out there were many rivers and streams leading to this low area, and there must have been quite a bit of water there. And relative to all of Sudan, there is the location of that lake in North Darfur. But also in Darfur, there is not just a lake, but we have Jabal Mara right here, provides a whole rain from every year from clouds that come in from the west, and the rain in here produced also some other features that would be useful. Here from the eastern part of the Jabal Mara, this is the southern part, the eastern part of Jabal Mara, all of these rivers come in, or the dry wadis now, but they used to be rivers during the time of rain. And all of the patterns of water anywhere in here, like for Al-Fashir, come in from fractures that actually hold this water that comes through. So we took all of this information and went to Darfur to tell the people within the government of Darfur, and showed them the lake, the boundary. And this is my standing next to me here is the Osman Kibir, the governor of Darfur. And we looked at all the potential. We had a helicopter from the United Nations that took us around to see some of the patterns of the ground and where the water may have passed and where did it end up and so on. And therefore we were able to find them some locations for future drilling to give the people of Darfur a little more space for utilizing water in agriculture because of the aridity, particularly in northern Darfur, and because of the lack of rain in most of the year. It rains on Jabal Mara only 2 months during the year. In addition to the radar images and the way we can see in the desert, in the flat desert, also that we have a great deal of our land is hilly terrain, like in the east, like the Red Sea mountains, both in Egypt and Sudan. There are a lot of very high mountain peaks, and there must be, when it rained in the flats, it must have rained on the highlands, same way. So we begin to think about where would water accumulate in the highlands. Because in the highlands, the rock itself is very solid. There is no porosity. Water cannot go into granite. So water would go into granitic rock only if that granite is cracked. Where would these cracks be? Along faults, along cracks, where the rock itself moves one side, moves to the other, causing earthquakes. The result is a crack, a fault, and within that fault zone, and the fault zone can be thin, or it can be thin as wide as this hole, then water would go through this. And that's the pattern from, if you are in the plain in the eastern desert in Sudan, this is the pattern that you can see. You see these lines in here and that line.